Welcome. So in this lesson, we're going to be talking about one-to-one functions. Let's begin by reading through some definitions. We've seen that a function is a special type of relation such that each x value maps to only one y value. A function is said to be one-to-one if different x values map to different y values. Another way to say that is that a one-to-one function cannot contain two different ordered pairs with the same second coordinate. All right, so again, sometimes when we read definitions, it can seem a bit confusing, but once we dive into some examples here, it will make a bit more sense. But before we do that, let's look at our diagram up here just to help us situate ourselves. So we know that everything is a relation. Everything is a relation. Then a special type of relation is called a function, and that's when each x value maps to only one y value. And now what we're learning is there is a special type of function called a one-to-one function. And this is when different x values map to different y values. So it's a special type of function. So this is kind of what we're picturing in our heads. Everything's a relation. A function is a special type of a relation, and then we've got something called a one-to-one function, which is a special type of function. Okay, with all that being said, let's dive into these examples here and see if we can answer them. It says, which of the following functions is one-to-one? So here it is right here, and the best way to approach this is the way in which we did it in the previous lesson, and that is we're going to first list out all of our x values. So we've got 1, 2, 3, and -4. So I've got 1, 2, 3, and -4. And then we have all my y values. So that's going to be 4, 2, 4, and 1. So I've got 4, 2, 4, so I'm not going to write that again because I've already got it there, and then 1. Okay, let's see now what's happening here and what maps to what. So this 1 corresponds to this 4 because that's what that coordinate is telling me. This 2 corresponds to this 2 because that's what that coordinate is telling me. And then do you see how 3 also goes to 4? So this is the important part right here. I have 1 and 3 both going to 4. And then finally I have -4 and 1, so it's just down here. Perfect. So now the question is whether or not this is a one-to-one function. And it's not a one-to-one function. So let's write down that it's not and then give the reason why. So it's not a one-to-one function. And then we're going to say as, now this is the reason, 1 and 3 map to 4. So it's the fact that I have two different x values mapping to the same y value. And if we come up and we look at our definition here, by definition, a function is said to be one-to-one if different x values map to different y values. So the fact that we have different x value mapping to the same y value means that it isn't one-to-one. Let's also give this a sketch. Okay, so we have the point 1, 4, so that would be 1, 4. We have the point 2, 2. We have the point 3, 4, and we have the point -4 and 1 over there. All right, we'll come back to this graph in a second. Let's move on to the next question first. All right, so we need to figure out whether this is one-to-one or not. So what we're going to do is we're going to list out all our x values. So we've got 1, 2, 3, and 4. 1, 2, 3, and 4. Then we're going to list out all our y values. So we've got 4, 3, 2, and 1. 4, 3, 2, and 1. And now we're going to see what maps to what. So 1 maps to 4, 2 maps to 3, 3 maps to 2, and 4 maps to 1. Do you see how each x value maps to a different y value? So therefore, this is one-to-one. So this is a one-to-one function. 1, 2, 1 function. And the reason why it's one-to-one is because different x values map to different y values. So different x values map to different y values. That's what makes it a one-to-one function. So let's just highlight our answers here. So we've got not a one-to-one, and we have a one-to-one function, and we have a reason for each of those. Let's now give this a bit of a graph. So I've got 1, 4. So I've got 1, 4. I've got 2, 3. I've got 3, 2. And I've got 4, 1. So it's actually a straight line there. Okay, now we're going to pause for a moment and see if we can figure out some sort of graphical way of determining whether or not we have a one-to-one function. So in the previous lesson, when we talked about functions, we saw that there was a graphical way of testing whether or not something is a function, and that was using the vertical line test. Well, looking at what we have here, do you see something that could tell us whether or not we have a one-to-one function? And hopefully you can see over here, do you see how horizontally both of these line up? And what that's saying is that, if I grab another color here, both 1 produces 4 and 3 produces 4. So because they're horizontally aligned, I can immediately tell you that this is not a one-to-one function because clearly my different x values do not map to different y values. So that therefore brings us, and let me get rid of these lines here. Get rid of those. We just care about this horizontal line here because this now brings us to the horizontal line test. So the horizontal line test tells us if a horizontal line can be drawn anywhere on the graph of a function and it only ever intersects the graph a maximum of once, then the function is said to be one-to-one. So looking back at our examples here, as you can see, I could draw a horizontal line here and it intersects it twice, once here and once here. So this is not one-to-one. But over here, I could draw a horizontal line anywhere through this and I'm only ever going to hit it once. So that is the horizontal line test. The horizontal line test is used to determine whether or not the function is one-to-one. So let's now give this a crack and go through these and see if we can figure out which of these are one-to-one and which of them are not. So I'm just going to draw a horizontal line through it. And as you can see, it intersects it twice. And because it intersects it twice, this means that this is not one-to-one. We come to our next one here. I could draw a horizontal line anywhere through this thing, and I'm only ever going to hit it a maximum of once. So this is 1, 2, 1. What about this one right here? Now, this one I might actually need another color here. It's just a horizontal line, right? So if I was to draw a horizontal line through it, I'm going to touch it an infinite amount of times because it's saying literally every x value gives you a value of 5 out. So if I was, for instance, to put in -3, I'm going to get -3, 5. Or if I was to put in 2, I'm going to get 2, 5. So different x values are giving me the same y value. So this is not one-to-one. So not 1, 2, 1. Okay, we keep on going here. What about this one? I could draw a horizontal line anywhere through this graph and I'm only ever going to touch it once. So that tells me that this is a one-to-one function because I'm only ever going to touch it once. So I'm going to write 1-to-1. It is a one-to-one function. And then last but not least, I have this graph here. If I was to draw a horizontal line through it, you can see that I touch it twice, which means it's not one-to-one. So it's not one-to-one. So that is a bit of an introduction as to what a one-to-one function is. Hopefully you can do the following. That is, give me the definition of a one-to-one function, be able to recognize one-to-one functions when given a series of coordinates, and also apply the horizontal line test to determine whether or not a graph is one-to-one. Hopefully you have found this useful.